Okay, this video is going to look at solving trig equations using radians instead of degrees. We use the same methods as we do with degrees, but it might be a good idea to first of all take a look at the sine, cos and tan graphs in radians and also the cast diagram in radians before we start trying some trig equations. So we'll look at the three diagrams first of all. Okay, so we have the sine wave, cos wave, put the tan wave in here. Okay, so we want to add our values on the x-axis. The y values are obviously the same. There's no amplitude on tan. Okay, so we know that 180 degrees is pi, so we could put pi in its location on the three graphs. That makes 360 degrees 2 pi because it's double 180, so that's 2 pi. Okay, half of 180 degrees is 90, so half of pi over 2 is going to be 90 degrees. And the last value that we probably want to put on there is 270 degrees. That's 3 lots of 90, so it is 3 pi over 2. Okay, so the graphs haven't changed in shape. The key points are still in the same locations, but instead of having 90, 180, 270 and 360, we have pi over 2, pi, 3 pi over 2 and 2 pi. On the next slide we'll have a look at the cast. Right, so onto the cast diagram. So we still have our all, sine, tan and cos. Instead of degrees though, we're going to have radians, so we have our 0, we have our pi over 2, we have our pi, our 3 pi over 2, and back round to 2 pi. Our angles within the quadrants are the same, so in the first quadrant we would have the angle x, or maybe theta depending on what you call it. That's the angle that the calculator gives us, 0 to pi over 2 or 0 to 90 degree angle. Into the second quadrant, previously we would do 180 minus x, so this time we do pi minus x. In the third quadrant it was 180 plus x, so it's pi plus x. And finally in the fourth quadrant it was 360 degrees minus x, so it's 2 pi minus x. So it is a good idea to be able to remember your cast diagram for degrees and radians for trying to solve trig equations in both forms. Now we shall look at 2 examples of solving trig equations in radians. Example 1. Solve 2 sine x minus 1 equal to 0, and this time it's going to be between 0 and 2 pi, our domain. So instead of 0 and 360, it's 2 pi, obviously, because we're in radians. And this here tells us to use radians. Because if you're given examples where you've got degrees and you've got radians, how are you meant to know which type you have to use? Well, if the domain involves a pi, you know you're working with radians. Now, the only difference to the method is that we're going to have to use a different mode on our calculator, and it's called rad mode, as in radian mode. And to get that, you have to press your shift, then your setup button. These are both near the top of the calculator. And then once you've got that, you've got an option list and you want number 4 for rad. Once you've set that up, that means that the calculator will give you answers in radians instead of degrees now. If you have your calculator in maths mode, it'll also give you them exact values. If your calculator is in normal mode, then you will have it as a decimal. So let's go ahead and solve. Well, the first thing we need to do is to rearrange 2 sine x minus 1 to get sine x on its own, just like the first step of a trig equation with degrees. So we've got sine x is equal to a half. We think about whether that is positive or negative, that function, and it is positive. So that will determine the quadrants that we need to use. We need to use quadrants 1 and 2 then, because sine is positive in the all quadrant, the first quadrant, and the sine quadrant, the second quadrant. We continue on by taking the inverse sine. Remember that was our shift sign button. So the inverse sine of a half, and that gives us pi over 6, which is equivalent to 30 degrees. Now the second quadrant, we need to do we need to do pi minus pi over 6, 180 minus the angle if it was degrees. So it's pi minus pi over 6. So that's our two quadrants. Now we don't need to do anything to the first quadrant. Pi over 6 is an exact value, so we can leave it like that, or you could have written it as a decimal. If we're going to try and solve the second one, you can do it in the calculator using the pi button, but we could think about taking a common denominator here. So we want the pi part to be written as sixth. So we need, oh, that's not very good, 6 pi over 6, if we write that as sixths, minus pi over 6. So basically I've just multiplied the pi by 6 on the top and created a denominator with 6 on the bottom, and that's given me a common denominator. So the final step then will be pi over 6 as our first quadrant answer, and our second quadrant, well, 6 pi minus pi is 5 pi. So 5 pi over 6. And that is our final answers for the first trig equation, and that's in rads. Now we'll have a second example. Okay, example 3. Solve tan x equal to minus a third. And that's going to be between 0 and 2 pi again. So we're still in rad mode. Right, so our function is already arranged so that we have tan x, the trig function, on the left hand side. So we just need to decide what quadrants we're using. So it's a negative function because it is equal to a negative y value, negative a third. So we're interested in when tan is negative. So we go to our cast diagram, and again, when is tan positive? Well, it's positive in the first and the third quadrants. So therefore it's negative in the second and the fourth quadrants. We're looking for the opposite two quadrants from the ones where it's positive. Because this is a negative function, when we take our inverse tan, we ignore the negative sign. So it's just tan to the minus 1 of a third. And this is going to be a decimal, so 0.322 rads. Now, that is the first quadrant answer, so that's the answer in here. But that's not one of the final answers that we're interested in. We're interested in the second quadrant and the third quadrant. So using that cast diagram, the second quadrant will be pi minus this decimal, pi minus 0.322, and on the fourth quadrant it will be 2 pi minus 0.322. And we work that out, we get 2.82 or 5.96 rads. Just before we finish up, just a reminder that when you're working in solving trig equations and there's degrees and radians involved in the calculations, make sure that you remember to change your calculator backwards and forwards between the modes. So to go back to degree mode, you would do shift, setup, 3. Okay, so that's how you would get back if your next question was in a degree mode calculator question.